Nice. We got a remainder. Sounds like there's a remainder. I like a remainder. Just as much as the next person. Okay, dokie. Well, okay, so when you do long division, you think about, does 12 go into the first digit? No, it's 2 digits. So does 12 go into 76? Yeah. 6 times. 72. 6 times 72. So I write the 6 here, and then I'm going to multiply.
Put 72 under 76, and then you'll get 40. Then you'll do 3, that'll be 30.
And then what do? So after I multiply, I subtract. And then you bring down. And then we start over. Well, we're going to do the same process in a minute with polynomials, and it'll look unrecognizable. So having the process fresh in your mind will really help you with that. All right, so yeah, now I'll start over. 12 goes into 43 times. Multiply. Subtract. Bring down. 3 again. Multiply. Subtract. Bring down. There's no more left to bring down. So we are going to, today, we're going to write remainders as fractions, as they should be written. So what's left? 7 divided by 12 still needs to happen. So it's 7/12. So the answer is 633 and 7/12. That's a fraction remainder rather than a decimal or a capital R. I don't know why. I guess because they teach you long division before they teach you fractions. So that's why they don't teach you fraction remainders back in the old elementary days. But yeah, remainders really are best understood as fractions. So you put the remainder over the divisor. All right, so do number 3 if you haven't yet. Who's done it?
Thomas. Oh my God.
All right, do number 3. Raptor, you ready? You had a full reveal.
Ready.
Do number 3. It's just right here.
Your student Thomas.
It's true. You can check with your calculator. Feel free.
Thank you. Okay, no problem. I'm not there.
Where's my pink pen? I'm about to jam. For this time.
I'll be in a time crunch. Here, I'll teach you.
Yes, we are. Interesting question. Are we in a time crunch? Life is a time crunch. Oh, it's meant to be enjoyed, I think.
And like, you can't be in a rush.
We'll go with Thomas. Thomas, does 24 divide into 13? We'll need another digit. How many times does 24 go into 130?
5. 5.
5 with confidence. Jeez.
I promise.
Subtract
The 3. Oh, I'm good now.
I think it's 4.
Oh,
What? Are you kidding me?
no joke.
You know what this means?
That we have our whole number as an answer.
Our answer is a whole number. No remainder means wait a minute. No remainder means 24 is a factor. Oh my gosh. Of 13,032. I didn't even know 13,032 divided evenly by 24, but now I do. That you could almost use long division as like maybe a method of factoring.
You learn something new every day.
So now we know that both 24 and 543 are factors. We're going to need that when it comes to polynomials. All right, before we do polynomial long division, let's check yesterday's homework. So open those books up to 325. 325.
325. Got it. Uh-oh.
My announcement is that from class yesterday.
Side outside. Don't even mind. Yeah. I'm excited. Probably not. About whatever it is, 35. Whatever it is, 25.
All right, here's 13 and 14. Distributive property.
Baseball. He's almost.
Finally did it on.
It was just 35. I thought we had to do 25.
Yeah. Oh wait, what did the dean say? What did Victor Kirk?
Alright, let's look at 21. I saw a lot of you did not get to the back. When you have to distribute into 3 binomials, the procedure is to ignore the third one and foil. Foil the first 2. And then after you're done with the first 2, you bring that third one in that you ignored and you distribute it. Lots of distribution.
I want to see if it's that number 35. I'm not sure.
Yeah, don't try to multiply through all 3 sets of parentheses. Do 2, simplify it, bring in the third one.
Oh.
It says see example 4. Let's just look at it.
Alright, Miss locked in.
So you guys, here's example 4. It does look really confusing, to be honest with you. That's the spirit. There's a lot of algebra 2 that is learned at home by yourself. That is a part of it. Alright, and here is 35. So, it's easy to think that this would just be like 2 to the third, 6 to the third, but that's not the case. You have to write out 3 binomials, foil 2, ignore the third, then distribute the third in. Question, Elizabeth?
Whenever I it is throw it Thursday.
I never heard
No, it was on TikTok. That could have hit his eye. That could have hit me in the eye. It's probably
Alright, our new word, page 4.3. Alright, let's head here we are, page 330. You guys, as we did work, I wrote down divide, multiply, subtract, bring down. Have you guys heard, does McDonald's sell burgers?
Yes, yeah, they do.
That's right. Okay, so What? Let's look. Oh. Long division of polynomials. When you divide a polynomial f by a divisor d, you get a quotient q and a remainder. The degree of the divisor, the degree, we've been talking about degrees, exponents, is less than or equal to the degree of the dividend. The degree of the remainder must be less than the degree of the divisor. When the remainder is 0, the divisor divides evenly. One way to divide polynomials is polynomial long division. All right, so what we have here is a quadratic that's being divided into this quartic polynomial. So big ol' L shape, just like what we just did with numbers. One really important thing here is this 0. After you practice this a lot, even this 0 is gonna mess you up even after lots and lots of practice. So what's with the 0? So this is the dividend. It's 2x to the 4th, 3x to the 3rd. 0x squared is not shown here. 5x minus 1. What do we think the purpose is of this 0? It's a placeholder. So every degree must be represented so that things are stacked correctly. So if you have a 4th degree polynomial in this dividend bit, you have to show x to the 3rd, you have to show x squared, you have to show x to the 1st, and you have to show a constant. So if one of your polynomials is missing an exponent, you got to put a 0 in that spot, or else it'll all be misaligned. Doesn't work. So the first and most important note for accuracy throughout the section is that every degree must be represented. If it's not, the whole lineup doesn't work. Okay. The most difficult thing to figure out is what to write on top. So when I look at x squared, I'm thinking to myself, what I really want is for x squared to turn into 2x to the 4th. So what would I have to multiply it by? Well, I have to multiply it by 2, and it's only x squared, and I want x to the 4th, so I need x squared as well. So I'm going to multiply by 2x squared. And then from there, it's, a distribution. So it's 2x squared times x squared is x to the 4th. 2x squared times 3x is 6x to the 3rd. 2x squared times 2 is 4x squared. So you distribute that to all 3 parts and then subtract down. 2x to the 4th minus 2x to the 4th cancels. That's the whole goal. If that didn't cancel, you picked the wrong number. 3 minus 6 is negative 3. 0 minus 4 is negative 4. 5, nope, that was it. And then you bring down the 5x, start all over. How do you make x squared look like negative 3x to the 3rd? You have to multiply it by negative 3. So then you distribute the negative 3 through. Negative 3x times x squared is negative 3x to the 3rd. Negative 3x times 3x, negative 9x squared. Negative 3x times 2, negative 6x. Subtract down. Negative 3 minus negative 3. Minus the negative is actually addition, so those cancel. 4 minus a negative 9 is a positive 5. 5 minus a negative 6 is a positive 11. Bring down the 1. Start all over. Down here, I know this is a remainder because this result is one exponent lower than this one. As soon as you get down to an exponent less than your divisor, you're done. The remainder is written over the divisor just like I wrote the remainder in number 1. So here's the quotient, 2x squared minus 3x plus 5. I do a plus sign, remainder over divisor. The good news is that most of our problems are shorter than this. I think they're like a binomial into a trinomial. This is a really nice long example though for you to always refer back to. All right, let's go ahead and turn the page and try number 1 on page 333. There are videos of this on Khan Academy. You guys all have a Khan Academy account. There are videos of this in YouTube. So here we go. X minus 3, great big long division bar, 2x squared minus 5. Okay. I'm focusing on the x, not the negative 3. Kind of ignoring the negative 3 for a while. I need x to look like 2x squared. So I'll have to multiply it by 2. And then this is only x, and I want it to be x squared, so I'll also multiply it by x. So 2x is what I'm going to multiply it. Deciding that's the hardest part, believe it or not. Because distribution is not too hard for you guys. You guys are all pretty good at distributive property. So 2x times x is 2x squared. 2x times 3 minus 6x. That's not the hardest part, for sure. And then you're supposed to subtract. So I got to put a minus sign. And we just practiced subtraction yesterday. So 2x squared minus 2x squared cancels. But now I'm doing negative 5 minus negative 6. Negative 5 minus negative 6 is actually negative 5 plus 6, right? Because minus and negative is really addition. So yeah, negative 5 plus 6x is 1x, or x. And then bring down the minus 3. Yeah, x goes into x 1 time. So the next number we're writing up top is 1. And distribute down. Subtract x minus x cancels, negative 3 plus 3 cancels, remainder 0. And you know what? We just factored. We found a factor. Remainder 0, this means you found a factor. So if you didn't like x factor, this is another way of factoring a quadratic using long division. Let's try number 3 next. Or maybe we should just go to number 4. Let's do number 3 next. I don't know. Let's do number 5 in your assignment. Let me do probably the most difficult problem with you.
Where is that? Wait. Is it on? That's on page 3.
Is page 337, number 1 through 5. I'm gonna do number 5 right now with you. Definitely get a separate piece of paper. This will take, that much paper. In case you were bored and in the mood for a challenge. Here it is. Here's your challenge. second one. Since they're both the same exponent, I actually think it's only going to be one little process. The ones that are the longest have like a really high exponent here and a low exponent here. So I actually think this might be just one go through. So I'll pick another one after this.
Yeah.
Wait, another one?
Well, you have to do 5. So I'm open to doing more. I should do number 2 or 2 of them. So I'll do this one and then I'll do number 2. Okay, so now I'm focusing all my energy on the first terms only. Are we ready? Is everybody ready? Yeah, let me wait. Does anybody want to talk about the yellow 0? Yeah, if you don't put that there, it's not going to work at all. So every exponent has to be shown. If you have a 3, you can't jump from 3 to 1. You have to have that 2 in there. The process doesn't line up. It'll wreck yours. And you won't even realize it's wrecked.
Does that mean if we have 4x cubed plus x squared minus 3, then we would put 0?
Yeah, exactly.
Where we have some, I think only like
Exactly. You can't line up an addition. Same thing with multiplication. Exactly it. You put it over the divisor. Just like I put 7 over 12. It's on the first term. Okay. What would I need to multiply 4 by to make it look like 8? 2. So that's what we put on top. A lot of people get really concerned about where do they write the 2 on top. It doesn't matter. I'm actually going to maybe write it all the way over here. It really doesn't matter though. It won't mess you up. Alright, and now I will distribute down. Boom. 2 times 4 is 8, and that's x to the third. And then this is the second hardest part. The first hardest part is picking the number to go on top. The second hardest part is subtracting correctly. Subtracting is kind of a bummer anyway. Okay, well, 8 minus 8 cancels. That has to happen. 0 minus 2 would be negative 2. Negative 2x squared. Negative 3 minus a negative 4. Minus the negative cancels, and that's really addition. So that's positive 1x. And 1 minus a negative 6 is really addition, so we got a 7. Now, as soon as your result down here is a lower degree than your divisor, you're done. So we're done now. This is a remainder.
that's the answer.
Let's write the answer out. So the quotient is 2 plus negative 2x squared plus x plus 7 divided by 4x to the third plus x squared minus 2x minus 3. Yeah, that's the big 2. So just like in this one, we took our remainder and we put it over 12. That's what we just did. All right, try number 1. Fine. Try number 2 next. It does make sense. It's an even, so.
Seems like something.
What?
No.
You will not escape it. You will spend a week next year doing this, no matter what. It'll show up on all of your high school math exams from now on, no matter what. Every Algebra 2 class covers it. every pre-calc, intro to college algebra, ACE math, all of them do it. Can't escape it. Just accept it, learn it, don't fight it. So this time we're doing X minus 5.
Ms. Baldwin, why do we always subtract it? Oh, it's 3. Like, why is there always
Well, with long division, you multiply, subtract, bring down, start over.
Oh, yeah.
It's the same process. Okay, I'm focusing my energy on this x and on this 3x squared. I'm not supposed to be writing like this. So, what do we think we're going to write on top this time? 3. And x. 3x up top. So it's pretty much just the coefficient, eh? So how come we're not doing any of it? You don't have paper? And Jasmine journeyed over there to get paper. And you had paper for multiple people, didn't you? When you went and got paper, it's just for you. Yeah. If only you could mind read Tyler also. Ooh, look at her. Do you have a pencil? Wow.
Okay, I did the problem.
She was paying attention though. Okay, now just further down. And subtract. Ooh.
Actually, I think number 1 is harder than this.
Yeah.
Yeah.
Number 2 is completely.
Where's the board?
Yeah, or not number 1, number 2.
Yeah. So the answer is what's written over the bar. So the answer is
Wait, why is it? Yeah.
That's the attendance. Oh, no, this one.
wow, we found a factor. I kind of like it better than X factor. Doing the same thing.
Wait, wait, how did we just one?
But for number 1, I don't know. So I think to myself, how many times or what would I have to multiply x by to make it look just like this x? So 1. So just when it matches perfectly, just put a 1 up there. And how was doing good and my question is 3. So 0, 0. Yes. You did 3 0? Yeah. What's tricky about
I kept on messing up the minus 1 getting over
What are you doing? Mm-hmm. Good work. But what's happening? Turn on
It's nowhere important by the way.
And then how did you get 5, 8, 9, 20?